Hello friends, welcome back to Python based data science series. In today's session, we are going to discuss about object oriented programming paradigm. Up till now, whatever the code we had written that was following the procedural oriented programming feature. It means everything starts from the main. The executions starts from the main, and what we did actually, that main process we divide into various sub process and then link up those all the sub procedures to the main processor. Means because of the scope limit, the data which is defined in a main process as well as the data which is defined in a sub process, they have their own scope limits. Because of that, most of the time in procedural oriented programming, we need to refer to the global data, as global data having access to the main process as well as the sub process as well, as discussed in this particular diagram. Now it leads a data insecurity. The data become accessible, data become insecure. The reason is its accessibility is anywhere else. The better terminology is wear and tear of data is possible because of its accession is not restricted, and it leads towards a limitation because procedural oriented programming having main emphasis is on the logic rather than the data. It won't be able to provide data secured solutions. You can just imagine an application which is going to produce a corrupt data. By wear and tear of data, if the end result is going to be faulty, then client point of view or the application development point of view, it is of no use. So to overcome these all the limitations, object oriented programming paradigm is formed. Paradigm means a program design. In case of object oriented programming paradigm, instead of keeping the data global and then make it accessible to the various procedures, why not we combine these both the two entities, that is data and its related functions, in one container, and then refer to the area where it has to be. It means now the scope limit is over. That data and its related functions are available in one scope, and it has to be referred from somewhere. In case of object oriented programming, the main striking features of object oriented programming is encapsulation, which is wrapping of data and functionalities together, popularly called as attributes and behaviors collection. The second striking feature is called as inheritance, which leads toward the reusability. The features which are defined in the base class can be extended to the derived one, and hence reusability can be achieved. In case of abstractions, it's a templatizing a base class so that we can override the features in the subordinate classes or the extended classes. In case of polymorphism, poly means many and morph means forms. One thing can be used for many forms. It's mainly the concept called as overloading. So these are all the striking features related to the inheritance, abstractions, polymorphisms, and encapsulations as well. We are going to discuss in the upcoming sessions. But right now, the main agenda is to overcome the limitations of structured and procedural programming, which was leading towards data insecurity. We need to follow the program design, and that design is of encapsulations or the OOP, object oriented programming. Here is another diagram. We'll come to know that how the procedures are divided from the main process. And here is the data collections, the collections of a data and functionalities together in one container and then refer from somewhere. Procedural language like a hierarchy, okay, the main and the sub functions and then again sub functions and then refer. And here the object-oriented programming consists classes, data abstractions, encapsulations, information siding, inheritance, and polymorphisms, and combinations of all these features is called as object-oriented programming. Object-oriented programming is always referred as a paradigm. To overcome the limitations of structured and procedural programming approach, we have to follow the programming approach. It's not a new language, it's an approach of coding that we enhance in case of OOP. To answer this simple question, what is object-oriented programming in Python? Object-oriented programming is a programming paradigm that provides a means of structured programming so that properties and behaviors are bundled into individual objects. Instead of keeping these properties, what I can say, but just defined as attributes and behaviors in the different scope, we need to bundle up in a one container that is called as objects. Means collections of properties and behaviors refer to the objects we can collect together. For instance, an object could represent a person with properties like a name, age, address, and behaviors, such as walking, talking, breathing, and running. Or it could be represent an email with properties like a recipient list, subject, and body, and behaves like adding, attachment, and sending. Every object have its own properties and its behaviors, and then these combinedly objects, properties, and behaviors referred to as an object. Put another way, object-oriented programming is an approach for modeling concrete, real-world things like cars, as well as relations between things like companies and employees, students and teachers, and so on. OOP models real-world entities as software objects that have some data associated with them and can perform certain functions. Another common programming paradigm is a procedural programming, which structures a program like a recipe in that it provides a set of steps in the form of functions and code blocks and follows subsequently in order to complete a task. The key takeaway is that objects are the center of object-oriented programming in Python, not only representing the data as in procedural programming, but in the overall structure of program as well. Procedural programming is more related to the division of main process into the various sub-processes. But as I explained, because of scope limits, we need to keep the data mostly in the global section to make it accessible anywhere else. And it leads towards data insecurity, wear and tear of data is possible. And to avoid that, we need to bundle up all the attributes and behaviors in one container. And that is what encapsulations means. Let us discuss all these steps theoretically, what we discussed up till now, practically. Let us discuss, we have to build a person class with the properties name and age. And we need to define the functionality for checking voting eligibility. Now, I define a class person. In the class person, every person class having the properties called as name and age. Now let us discuss about what is this init means. It's a constructor. As I said, we have to wrap the two properties of a person class name and age. So if you write over here the name and age, you have to initialize the data. But in case of class is a prototype. We have to initialize the data belongs to object at the runtime environment. So we'll be defining constructor. In Python, we'll define the constructor by def, define init. And then this is the self. Self in the sense it is referring to the object. In a programming languages like C++ or Java, it can be referred as a this pointer. But here in this Python, in case of Python, we refer as a self. Self means referring to the object who is referring to this particular method. Self name comma age means whenever you create an object of person class, the arguments of name and age will be passed on, and that values will be initialized to the properties belong to that object. So define init is a constructor which will take name and age as an argument from the user and initialize the properties belongs to that object which you are creating. And then there is a method called as check. But we need to understand one thing, that all the methods belongs to class need to have a self as an argument, because that self, as I just explained, belongs to the object which is referred. Define check self. So if self dot age, now this self dot age is actually referred to the object who is going to give a call to this check method. There is only one class, but there may be many objects. So to distinguish the properties belongs to that object, the self reference is important. If person P1, person P2, person P3, it means person is a class, but P1, P2, P3, these are the objects. Now, whichever the object, if P1 gives a call to check, it means this self is referring to P1. P2 dot check, it means now my self is referring to P2 object. So to distinguish between the properties of which object, we have to use a self. So if self dot age, whichever the object gives a call to check, if self dot age more than equal to 18, it returns true, else returns false. It's a method just to check whether the person's age is eligible to vote or not. Then I define a method called as show, which is useful for displaying the properties of that object. It will return self dot name and the space and age. The value of properties of that object can be written. Then I'm having a main definitions where I initialize object of person class. P equals to, now P become an object of person class, P equal to person ABC and 12. Here ABC and 12, I'm assuming person name and the age. It gives a call to the parameterized constructor, and the private data or the attributes of that class will be initialized. Means P become an object with the name ABC and the age 12. In this manner, we can create many more objects of one person class. Now here print person details p.show. Now show is a functionality, or show is a method which is referring to the object and returns its attributes. So p.show will give me return ABC and 12. Then if p.check, we have a definition of check which is referring to the object and return whether he is eligible to vote or not. If it is returns true, it will say that p.name is eligible to vote. It refers to the name and eligible to vote, else it is printing not eligible to vote. And here is the definition of a man and referring to men. Let us go for the executions. Hope you understand the program design of this person class. It is a bit different than the procedural programming, because in procedural programming we read the data and give a call to the functions, but here in this case we wrap the data, we initialize the attributes, we wrap the data, we define the functionalities, and then in the main we create an instance and initializing attributes and then give a call to the methods. So instead of top to bottom programming approach, we are following bottom to top programming approach, and this is also a way of dealing with object-oriented programming. Let us go for execution. Here it is. Person details ABC is a name and 12 as a age, and ABC is not eligible to vote because he is having a age 12. Now if you can construct another object by the name of PQR, but he is having an age 22, and now if you run the code, person details is PQR with age 22 and he is eligible to vote. If required, we can create any number of objects of a person class. And refer to all these methods. And you can even able to check the eligibility of Q as well. Let us discuss one another example. Now after discussion with the person class, let us switch to the another class called as student. Now whenever you refer to the student object, you'll come to know that students have an attribute like name, roll number, subject marks, total, percentage, because the objective of student class may be generating the score sheet. So here I construct a class student. In the constructor, whenever an instance of student class generated, I am getting data related to the name, roll number, and 5 individual subjects marks, and by that I am initializing the attributes belong to an object. So self.name equals to name, self.rn equals to rn. Now self means that object's property will be initialized by this local data passed on by the user. Then I am having a method called as compute, which is referring to the object and compute the total and the percentage. As we know, to compute the total, I should be cumulate all the subject score, as well as to find out the percentage. Total divided by 5, okay, into 100 divided by 500, it means total by 5. It's a formula, and we are converting it into the float, because integer by integer is integer. Here it will convert into the float, and in this manner percent can be evaluated. Then I'm defining a method called as display, which is displaying all the details of a score sheet of that individual student, here in the format of name, self name, roll number, the subject's marks, all the subject's marks, and the total and percentage can be displayed. Now in the bin, I'm going to create an object of student type, which is having name ABC, the roll number 101, and these are the subject score. Then S dot compute will compute a total and percentage for that particular students, and S dot display will display the score sheet in the specific format. And then here we are referring the men. Let us go for the executions and test whether my code OOP code is going to generate the mark sheet for me. Here it is. Name ABC, roll number 101, subject score we are having individually. The total is 403 and the percent of it is 80.6. You can update further by accepting the dynamic values from the user and pass it on to the constructor of student class, and then you can compute and display the score sheet of a student. The programming approach what we are following, that is object oriented. We need to start with the class. We need to define the constructor by which you can initialize the private data or the attributes belong to the class. And then you need to define the methods. Here self is referring to the object because your class is a prototype but your object is an instance. So the attributes you have to initialize to that object, and that too from the runtime environment. So these all the values which you pass on will be initializing the attributes of that object, and then you can process that data. This is called as object-oriented programming approach. Now let us go for the another example to understand this programming approach, that is bundling of properties or attributes or behaviors or the functionalities together, and then through the instance we can refer to that. Now we have an arithmetic class. Now whenever we are saying arithmetics, means we know that we need minimum 2 numbers by which we can perform all the possible arithmetics like addition, subtraction, multiplication, division, modulus with these 2 numbers. Now here in the constructor of arith class, I am having 2 integers passed on from by the user, and by that attributes of that arith class will be initialized. Then I am having a display which displays the data of 2 numbers, and then I am having a method called as add which will perform the addition, likewise subtractions, multiplication, division, modulus. These all the type of methods I define to perform the arithmetics with the given 2 numbers. I am following the bottom to top programming approach, because if you are a procedural-oriented programming, probably you will accept 2 numbers and try to perform all the possible arithmetics step by step manner. Here I am just building a prototype first. Okay, I am initializing the attributes of that class as well as, and then display it and then perform all the operations. And then here I create an instance of arithmetic class 80 equals to arith 5,7. Now 5,7 are the 2 integers on which I have to perform the arithmetics. Numbers for arithmetics, 80 dot display will give me 80 dot display. 80 is an object, so self will be referring to 80, and it returns the values of A and B. And then here whenever you refer the methods called as add, subtract, multiply, divide and modulus, so it will return the computed values for all this process. In this manner, by accepting dynamic values from the user, you can able to perform all the possible arithmetics with the 2 numbers. My today's session was related to the how we can deal with object-oriented programming using Python. We need to start with the class, we need to define the parameterized constructor, we need to define the various methods, and then in the main we need to accept the dynamic values, we need to create an instance and refer those methods. Hope you understand and enjoy the object-oriented programming feature. Thank you.